We're in the MC Machinery showroom. We're going to be learning from the experts beside us about graphite milling and EDMs. We're at MC Machinery in Chicago, Illinois. We're sitting in front of the HC
658.
Awesome, thanks, John. And I want to know, John, what is this machine best used for?
This machine is best used for graphite machining. It's set up specifically for dry style cutting with no external lubricants.
Okay, so now graphite, I understand it gets into a lot of parts of the machine. You got dust, you got grime buildup on the table. But is that the case with this, or how does it handle?
No, it isn't. Roku has really designed this machine to be keep all the dust and grit out of any of the major components. So it is sealed very tightly on the inside to protect all the critical surfaces.
How hard is it to set up on this machine?
It's very easy. We integrate a spindle probe, which is usually a Renishaw OMP 400, so a very good probe. And we also have a laser tool setter on this machine. That way, at any time, we can be setting the tools right prior to cutting. And at the end, we can also check and make sure that tool hasn't broken throughout the process.
And then what about like smoke removal? Because we're watching it run right now, and it looks like that smoke's just disappearing.
So it comes with a vacuum system, and the system is plumbed throughout the entire casting to pull all the dust and grit out of the machine as it's cutting.
That sounds like a super important feature because...
It is, because graphite machining is, especially in the mold world, it's one of the worst operations that there really is out there. It's dirty, the dust gets everywhere. If your machine's not sealed, if you're not pulling that out, it wears the components out dramatically.
Yeah, and now we're in front of Roku-Roku, and I was talking to another John the other day, and he was explaining this is Japan's oldest machine builder?
They are.
So they bring a little bit of experience to the table.
They bring a lot of experience. You know, they started in the 1900s and have been around for a long time, you know, and they've been building the machines the same way since they started. You know, hand scraping the ways and mating up all the matching surfaces.
So with all of that experience, how is the rigidity of this machine, the accuracy and the repeatability of it?
Very good. We see, you know, a tenth is really common for us to hold on this machine all day. We don't see much in the way of thermal shifts because of the thermal comp that Roku has on it. So we stay pretty tight.
Awesome. So what industries do you see taking the best advantage of a machine like this right now?
Really all industries. It's anywhere where you have those details where you can't get in it with a milling cutter. Sharp corners is a real good example. But we see them in aerospace, medical, injection molding, defense. Virtually anywhere you can see a sharp corner in anything is where you're going to find a graphite machine.
This machine that we're standing in front of right now actually has a really cool tower behind us. So what's the relationship to the machine tool?
So that's an automation cell that we put onto this machine. Because as everybody knows, when you do your electrodes, they wear, so you always have multiple electrodes that you have to use. So by putting the robotic cell on it, it's one program and we can run all of those lights out overnight or over a weekend if you so desire. It really gives you a lot more spindle uptime.
Spindle uptime is important for anyone watching out there right now.
It is. You know, when you're looking at 10, 15 years ago, where your spindle time was about 40%, where now we see them 80 to 85%, and then, you know, a real best case, about 90% spindle uptime.
So John, we're talking about graphite in this machine. Can you use it for anything else?
Yeah, it's also capable of doing steel. You know, the caveat is between this one and the other Roku machines is that you wind up cutting dry. It doesn't mean that you're going to lose your accuracy. Your tool life probably won't be quite as long as what it would be with a lubrication system, but you're still going to be able to do the hard materials, you know, all the way up into the carbides. But we also do copper as well in this machine, just using an air blast. And with the addition of a probe and a laser setting system on it, you know, there's really nothing that this machine can't do.
Well, thank you, John. I'm going to jump to the other side of the cell, and we're going to go talk to Pat to learn about the sinker side.
Sounds good.
Pat, I was just over there talking to John on the mill side about graphite milling. Now we're on the EDM sinker side. I know nothing about EDMs, okay? What's important when it comes to sinker machining?
So you got to keep in mind, on a sinker EDM, it's all about the spark. So making that spark and picking the right spark.
Okay, so how does the SV12P help in that regard?
It really in two ways. It helps you by having a very strong database to create technology. So it has a lot of different materials, a lot of different electrodes to burn it efficiently. The other thing, and what really makes the machine special, is the adaptive control system. IDPM Fuzzy 3. What that is that's a system that allows, the biggest thing about EDM is that a lot of things change as that process is going in. Surface area is changing, contamination's changing, all these things going on. Having a system on the machine that acts as an AI and makes adaptive movements to the technology to make sure that it's still efficient, will speed up if it can, slows down if it needs to.
So if I'm understanding right, controlling the spark is there, and this adaptive control makes it possible on the SV12P to really hone down that control of the spark.
Yeah, get the best speed and the best safeties out of the control.
So we were just over there making the electrodes on the other machine. Obviously those are a consumable part from what I understand with my basic understanding.
Correct.
How does the SV12P help reduce the usage of those electrodes?
So the biggest part, like any production job, any job on the EDM, the biggest cost is the electrodes. So if you can control the spark where you're getting very little wear on the electrodes, means that you're going to be more productive and you're going to save more money. Almost any production system we do on these, it always comes down to electrode costs. If you can bring the electrodes costs by having an excellent machine like the Roku, and you can use those electrodes more.
So something, Pat, and you can correct me if I'm wrong, you're the expert here, but what I understand that sinker EDM work is kind of slow. So what are some of the things that MC Machinery has done to help take advantage of that time or reduce that time where someone has to stand here?
Sure, I mean, any EDM, if it's going to be profitable for you, you want unattended time. And there's a lot of processes where, in a lot of medical parts, where there may be a quick turnaround between a part getting started and a part getting done. So it's good to have a system like this where you can change out electrodes, you can change out parts, and you can run over a weekend. You can run 3 or 4 days at a time before coming in and swapping out parts.
Pat, with all of that automation, what systems are there to help me know that it's actually being done right?
Well, you can build into any of the systems. It's built into the process where you can have the program automatically use the probe like we are here in the machine to pick up your part. And it can do up to 100 parts at a time on every different pallet that may be brought in. So it gives you a lot of flexibility to be and trust the machine that it's going to be accurate.
Pat, what are some of the difficulties with EDM sinker work?
You know, the fundamental difficulty is that you can only make as many sparks as you can remove contaminants. So one of the best ways to remove contaminants is using one of our new SS jump features, right? With that SS jump, you remove contaminants very quickly, so you can come out of the cavity, come back in, and very quickly back to making sparks. That is what's removing the materials.